In this video, I'll talk about matrices for combining transformations in R2. So for an example, let's suppose we first reflect in the x-axis, which is given by this matrix here, 1, 0, 0, minus 1, and then we rotate 90 degrees clockwise, which is given by this matrix here, 0, 1, minus 1, 0. So if we think about this in terms of this diagram here, we're starting at the point xy, and first of all we're reflecting in the x-axis. So we're going to go from here down to here. So let's draw that. Maybe let's draw that in green. So we're going to reflect across the x-axis, and we're going to be at this point here, and then we're going to rotate 90 degrees clockwise. So let's draw the diagonal that's going to this point, and then we're going to rotate 90 degrees clockwise. So 90 degrees and rotate clockwise round to this point, so we'll end up at this red point here. And let's think about what that is going to look like in terms of coordinates. So we started at the point x, y. Maybe I'll write that down on the side here. We started at the point x, y, and then we went to the green point, which is x minus y, and then we went to the red point, and the red point is going to be in the x direction. It's going to be minus y, and in the y direction so minus x. So that's where we're going to end up. So let's see how to combine those transformations into a single transformation. So which transformation would get us directly from this point here over to this point here? So let's write this down in terms of matrix multiplications. So first of all, we're reflecting in the x-axis according to this matrix here, 1, 0, 0, minus 1, and we're multiplying that by the starting point xy. So that's what's going to take us to the green point, because it's going to take us to x minus y. And then we're going to apply the rotation matrix 0, 1, minus 1, 0 to the green point to take us to the red point. So we're going to have to put the matrix 0, 1, minus 1, 0 on the left of the matrix we've already written down. Okay, and this often trips people up because they'll often think to themselves, okay, well, I'm first applying this matrix 1, 0, 0, minus 1, then I'm applying this matrix 0, 1, minus 1, 0, so I ought to have this matrix and then this matrix. But if you think about how you're applying the transformations, you're applying this matrix first to the vector, and then you're applying this matrix to the result of that transformation. So the second transformation matrix has to go on the left of the first transformation matrix. So let's simplify this. So let's multiply these two matrices together. So we're going to end up with, so first of all, inner product of 0, 1 with 1, 0. It's going to be 0. And then inner product of 0, 1 with 0, minus 1. So that's going to be minus 1. And inner product of minus 1, 0 with 1, 0 will be minus 1. And inner product of minus 1, 0 with 0 minus 1, which will be 0. So we'll end up with the point minus y minus x, which is exactly what we expected to get.